astronomers continue to unravel the enigmatic workings of the universe, this time with collisional ring galaxies, a distinctive class of interacting galaxies notable enough to deserve their own classification. While the dynamics of galaxies interacting might suggest chaotic and amorphous outcomes, ring galaxies seem to bring order amid the complexity. In a recent study, a group of scientists gave us a fresh insight into one of these collisions that gave its peculiar form to the Bullseye galaxy. Using the Hubble Space Telescope, the team identified 9 concentric ring structures within this galaxy. Several of these rings are densely clustered near the galaxy's core, while others span tens of kiloparsecs. Notably, 2 of the outermost rings are actively forming stars, and those are encircling inner rings that are characterized by a striking reddish hue. Complementary ground-based observations also reveal faint patches at greater distance, hinting that there is a 10th ring that gradually faded from view. CRGs like the Bullseye galaxies emerge from head-on collisions where a smaller galaxy plunges through the center of a more massive disk galaxy. This violent encounter triggers a density wave, generating expanding rings that ripple outward from the impact site, just like throwing a rock into the water. The Hubble Space Telescope and other observatories have documented additional examples of CRGs. One of them is the Cartwright Galaxy, which has a brilliant outer ring teeming with star formation, connected to a central ring by faint spiral-like arms of lower surface brightness. Similarly, the Hawks object presents an almost perfect ring encircling a yellow nucleus of all stars, contrasted by an outer ring rich with clusters of young massive stars. Another striking case is known as AM 0644741. This is a ring galaxy whose shell-like shape is bright thanks to the massive young star clusters. At its center, it is a yellowish core that looks like a pearl. This is the remnant core of what was once a typical spiral galaxy. From observations of these and other CRGs, astronomers conclude that their rings will continue to expand and dissipate over time, potentially evolving into a different class of cosmic structures known as giant low surface brightness galaxies, or GLSBs. Some examples of these other type of objects are UGC 1382, also known as the Frankenstein Galaxy, and Melin 1 and Melin 2. Though CRGs and GLSBs remain rare, astronomers anticipate that the upcoming surveys with the Large Synoptic Survey Telescope, or LSST, and the Subaru Telescope will uncover more of these elusive systems, further illuminating the dynamical process shaping of universe. If you like the information in this channel, please remember to subscribe.